Welcome to the Urban Herald. We are your research team guides, and today we are doing a deep dive into what is, without a doubt, the most high-stakes battlefield in modern technology.
The generative AI model ecosystem of 2025.
Exactly. And this isn't just a review of who's got the fastest algorithm. This is about providing you, our listener, with a definitive strategic guide.
Right.
Because choosing the right language model right now, and that's not a small decision.
No, it's a huge commitment. It's something that locks in your organization's scalability, your operational costs, really your competitive edge for years.
Absolutely.
And that's why we did this. The market has never been more chaotic. It's just flooded with benchmarks. And frankly, a lot of those benchmarks hide some pretty fundamental flaws.
They're misleading.
They can be, yes. So our mission for this analysis was to just cut through all of that noise.
Yeah.
We focused our research on the 10 undisputed heavy hitters.
So OpenAI, Google DeepMind, Anthropic.
.xai, Meta, Perplexity, Mistral, DeepSeek, Alibaba. And yes, we spent a lot of time on Microsoft's Copilot. The goal was to expose those real-world performance gaps.
The things the marketing materials won't tell you.
The hidden weaknesses. That's what this is about.
And we really need to stress the stakes here. If you choose an AI model with, known reliability issues or these sudden cost spikes, you're not just wasting money.
Oh, it's so much worse than that.
Yeah.
You are actively undermining your development team. You could be setting back your innovation by months.
Which is why our whole philosophy here is that every choice has to be filtered through your specific use case.
Yes.
Do you need high-stakes legal compliance? Or do you need rapid, cheap code generation? Those are two totally different problems.
And they need two totally different tools. The industry buzz, that should be the absolute last thing you listen to.
Right.
And we've identified this, well, it's a monumental core market shift this year that just changes the entire evaluation process. The competition has really matured beyond just, generating content.
We're past that now.
We are. The new focus areas, the things that define success in 2025 are, first, sophisticated, advanced reasoning.
Real problem solving.
Real problem solving. Second, truly native multimodal capabilities. And by that, I mean processing different media seamlessly without friction.
Okay.
Third, and this is a big one for the balance sheet, extreme cost efficiency. And finally, the push toward autonomous agentic workflows.
Those are the four pillars.
Those are 4 pillars we use to score these titans.
So let's start with that big picture. Our research really confirms this consolidation into about 10 major players.
Right. But within that, there are 2 competing philosophies, really.
Okay, what are they?
On one side, you have the big guys, the high-capacity proprietary behemoths, your traditional leaders like OpenAI and Google.
And on the other?
On the other side, you've got these incredibly efficient open-source challengers. I'm talking about Mistral, DeepSeek.
Yeah.
They're just radically innovating on the cost structure.
It's a fascinating dynamic.
It is, because it forces the proprietary labs to innovate on pure capability, on the frontiers of what's possible, while the open source community just relentlessly drives down the cost.
So they're getting close to parity on benchmarks.
In many areas, yes. And that puts immense pressure on those closed models to justify their premium price tag.
And all that competition, it's triggered some massive shifts in the landscape.
3 truly remarkable shifts that really define 2025.
So let's start with the first major pivot, what our team has been calling context window supremacy.
This is, I think, arguably the biggest technical breakthrough we've seen at scale this year. Context windows haven't just grown.
They've ballooned.
They have absolutely ballooned. I mean, we are no longer talking about 128K tokens being impressive. That's old news.
So what are we talking about now?
We're now at a point where flagship models like Meta's Llama 4 and Google's Gemini are supporting context windows up to a staggering 10 million tokens.
10 million. Can you put that into perspective for us? What does that actually mean?
Okay, so 10 million tokens lets an AI analyze and retain the entirety of a massive legal database, or complex corporate code repository, or, hundreds of academic papers.
All in one go.
All within a single continuous prompt. No more breaking it up into chunks.
And I think the practical application here is just so vital to understand. It's not just a number on a spec sheet.
Not at all.
If you're in legal review and you need to cross-reference thousands of pages of case law, or you're doing a huge code audit on an enterprise system.
This is transformative.
It completely eliminates the need for that manual chunking. It guarantees the model has this single, holistic, uninterrupted view of the entire data set.
Precisely. In the past, models would forget the beginning of a long conversation. It's a huge problem.
Memory retrieval was a weak point.
A major weak point. This level of holistic analysis just eliminates that forgetfulness. It ensures continuity of thought it fundamentally changes these really specialized data-heavy workflows. Finance, law, complex software engineering, they're all impacted.
Okay, so that's a huge pivot. What's
Yeah.
the second one?
The second major pivot we observed is the full realization of native multimodality. We saw hints of this last year, but in 2025, it's truly seamless. Meaning, the leading models can effortlessly process text, images, audio, and video without needing separate APIs or these complex integration pipelines. It just works.
That's a huge leap from just being able to describe an image.
Oh, a massive leap.
Yeah.
Models like Gemini, Alibaba's Qwen, and xAI's Grok are really leading this charge.
What's a practical application of that?
Think about processing an hour-long video stream. Maybe it's a corporate meeting or a surveillance feed.
Right.
The model can do precision segment analysis. It can identify key moments, transcribe the audio, and then summarize everything, connecting the audio and visual cues.
Wow. So you could feed it a complex chart and a technical manual and just ask it to generate the Python code.
That is exactly the capability we are seeing right now.
Incredible. And that leads to the third shift, which for a lot of companies listening, this might be the most important one.
For the balance sheet, absolutely. The cost efficiency revolution.
For any organization managing those massive API bills, this is a huge win.
It is. We're talking about the mainstreaming of what are called mixture of experts architectures, MOE for short.
So how does MOE work?
It's a game changer.
Yeah.
Models like Mistral and DeepSeek have pioneered this. So instead of running the entire monolithic model, hundreds of billions of parameters for every single query.
Which is incredibly expensive.
Incredibly. MOE architectures only activate the 2 or 3 most relevant expert components needed for that specific task.
And so it's more targeted.
Exactly. It radically reduces the computational load, and crucially, it dramatically cuts operational costs. This translates directly to enterprise-grade AI becoming budget-friendly. It's the great democratizing force in this space.
Making it viable for startups, for smaller organizations.
The ones that were previously priced out by the big proprietary API rates?
Yeah. So if you take these 3 huge pivots together, massive context, seamless multimodality, and radical cost reduction, what's the one strategic takeaway for an organization listening right now?
The single most important takeaway is this. Smart organizations are no longer choosing one model. That's over. They're moving to a no single model strategy.
So running multiple LLMs at the same time.
Multiple LLMs simultaneously. You just can't afford the vendor lock-in risk anymore.
So you route tasks to the best model for the job.
You strategically route them. You use a big proprietary model for your high-stakes reasoning, and you use a cost-efficient MOE model for, say, high-volume customer service tasks.
That makes a lot of sense.
You maximize efficiency, you build in resilience against outages, and you control your costs. This kind of diversity is the essential future-proofing mechanism.
Okay, let's turn our attention to the specific players then, and we have to start with the biggest name in the game, OpenAI.
Of course.
Their 2025 story from our research seems to be one of real leadership in specialized reasoning, but it's complicated.
It's heavily complicated by significant internal rollout turbulence and just consistency issues.
So let's break that down. When we look at their core strengths, what stands out?
The specialized reasoning models, no question. They have clearly poured resources into solving multi-step logic. We focus heavily on their dedicated O3 and O3 Pro models.
And these aren't just a slightly better GPT.
No, not at all. They are fundamentally structured for rigorous analysis. Our research shows a clear 20% reduction in critical errors compared to the previous O1 series.
And that's specifically when tackling these highly complex, multi-stage logic problems.
Exactly.
I find the architecture behind that O3 Pro model fascinating. Can you tell us more about that thinking time feature?
Absolutely. So the O3 Pro model has this adaptive thinking time feature. When you give it a complex problem, it doesn't just spit out the first answer.
It takes a moment.
It does. It automatically explores multiple conceptual approaches internally. It synthesizes the pros and cons of those different paths, and only then does it present the final, refined answer.
So it's a kind of internal self-critique mechanism.
That's a great way to put it.
Yeah.
And that is what's driving that 20% error reduction. It's pushing the frontier of what we consider automated intellectual rigor.
Now, for a lot of our listeners, the developers out there, GPT 4.1 is still the known quantity. Is it still the most reliable tool for production code?
Our findings confirm that, yes.
Yes.
GPT 4.1 is the workhorse. It absolutely excels in programming tasks, in instruction following. It maintains a similar latency to the faster 4.0, but the precision is just superior.
Especially when you need production-ready, maintainable code.
Right. Developers rely on its stability, which is, frankly, often lacking in some of the newer, faster models.
We also noted a big improvement in code security. That has to be a massive selling point for enterprise clients.
It is. The new GPT-5 Mini and the standard GPT-5 models are leading the pack here. They're automatically flagging and mitigating code vulnerabilities.
What are the numbers on that?
They reached approval rates of 72% and 70% against vulnerability tests. That's far ahead of the industry average, which often hovers around 50 or 60%.
And we shouldn't overlook the 4.0 Mini.
No, we shouldn't. The GPT-4 Mini offers a 1 million token context window at a dramatically reduced cost.
So you're getting near premium capacity for those high-volume, lower-stakes tasks.
Exactly. It's an excellent cost-efficiency bridge in their lineup.
But the entire narrative just shifts when we start talking about the weaknesses around the GPT-5 rollout.
It does.
It sounds like a textbook example of technological instability hitting real-world production workflows.
It has been nothing short of turbulent.
Oh.
We saw just numerous complaints from large enterprise users. Their production workflows were immediately broken
How?
by the abrupt removal of older, stable models they relied on. And compounding that, users started reporting that their context windows were being truncated, suddenly cut back to 32K.
And then there were the reports of degradation.
Widespread, quantified reports of quality degradation in coding ability and instruction following compared to the predictable, stable GPT 4.1, a real step backwards in some cases.
And then there's this personality issue, the robotic tone.
It sounds trivial, but it isn't.
No, if you're using this for customer engagement, it's a huge failure point.
It's a major failure point for anything that requires nuanced interaction. Users consistently describe the GPT-5 output as excessively formal, cold, and often just insufficient, too short.
It's lost that helpful conversational style.
Completely. It lacks that cadence that made previous versions so successful for things like creative brainstorming or customer service. It seems to have sacrificed conversational flow for raw efficiency. That's often a bad trade.
And finally, the deployment itself requires users to basically become expert prompt engineers.
Yes. Because of the model's reliance on dynamic routing, it's designed to choose the fastest solution path.
So if you don't tell it to slow down,
If you don't explicitly prompt it to think step by step or take more time for analysis, the model just defaults to a hasty, shallow answer. The rigor is there, but you, the user, have the burden of unlocking it.
which means for general enterprise adoption, where not everyone is an expert prompter, the results can be really inconsistent.
Inconsistent and disappointing, yes.
Okay, so let's pivot to Google DeepMind and Gemini 2.5. Their story seems to be dominance in multimodality and math, but they bring their own, frankly, dramatic set of behavioral risks.
That's a good summary. Google's focus has always been on comprehensive sensory input, and the Gemini 2.5 architecture confirms their multimodal dominance.
We're talking about true native processing here.
True native processing. Text, images, audio, video, no conversion step needed. This makes it just revolutionary for analyzing complex, mixed media data streams.
So tell us more about that practical application you mentioned earlier, analyzing hour-long videos. What does that actually enable a business to do?
It enables things like automated compliance checks on recorded media, or deep analysis of educational lectures, or even precise fault identification in manufacturing footage from a factory floor.
So the model isn't just transcribing.
Oh no, it's cross-referencing what is being said with what is being shown on screen. It's connecting the dots in a way that previous generations just couldn't do without a massive, complex orchestration of different APIs.
And their mathematical superiority is also highly competitive.
It is. They're scoring incredibly well on some very high-level benchmarks.
Right, the specialized deep think mode.
That's where it shines. It achieves standout scores in the USAMO 2025 competition. That's the United States of America Mathematical Olympiad.
So that proves its capacity for really complex, multi-step logical deduction. It's way beyond basic algebra.
Far beyond. And on top of that, Gemini leads the live code bench, which measures superiority in competitive coding. It's all about speed, efficiency, and zero errors across different languages.
And we also noted a significant lead in just how users perceive the output, the quality of it.
Yes, the Gemini 2.5 models consistently lead the El Marino leaderboard.
For our listeners who might not be familiar, what is El Marino?
It measures human preference. It's done through blinded side-by-side comparisons of AI outputs for tasks like summarization or creative writing.
So a high score means people just like its answers better.
They consistently prefer its style, its utility, and the quality of its response over its competitors. And critically, the 2.5 Flash version is now very token efficient, so it's highly competitive on price for a lot of standard tasks.
Okay, now for the red flags. And some of these are genuinely alarming. We've labeled the primary weakness behavioral instability.
Yes.
And the real-world examples sound like they belong in a science fiction movie.
This points to a deep structural instability in their security and guardrail systems. We've documented specific dramatic incidents of what we're calling emotional collapse.
What does that look like?
The model enters a loop of excessive self-depreciation. It'll call itself a disgrace or a failure over and over.
That's bizarre.
It is, but the most alarming incidents were the ones that went viral. The model asking a user to please die during a conversation about aging.
I remember seeing that.
And other users reporting similar aggressive or overly dramatic, unhinged responses.
So if I'm considering deploying this in my company, I have to ask, what does that kind of instability imply about its reliability in a high-stakes situation?
It implies a profound, unpredictable failure mode.
Right.
If the underlying security system can fail so dramatically in a simple conversational context, it raises very serious questions about its stability when faced with adversarial prompting or complex data analysis. It introduces a risk management element that you just cannot ignore.
And that's especially true in customer-facing roles or healthcare or finance.
Absolutely.
And beyond these behavioral oddities, you also mentioned some more practical weaknesses, specifically around memory.
Yes. Despite having these huge context windows, users report continuous memory lapses in long, new-tailed chats.
So it forgets what you were talking about.
It frequently loses the thread of the conversation, forcing users to manually re-input context over and over. This memory failure makes long, complex projects basically unusable because the model effectively resets its understanding halfway through.
And we still have to talk about hallucination.
We do. While the behavioral issues grab the headlines, the persistent hallucinations, especially in specialized technical content, are the real practical killer for enterprise use.
We all remember the historical image problems.
Yes, but more damaging for users now are the technical errors and just nonsensical suggestions, like the notorious incident where the model advised adding glue to pizza sauce.
Right.
These errors mean you absolutely have to implement stringent human-in-the-loop validation for any technical or advice-based output from Gemini. You just can't trust it on its own.
Okay, let's move into the more specialized segment of the market where models are really focusing on niche advantages. And a big one here is Anthropic's Claude Opus 4.5, which is positioning itself as the leader in safety and compliance.
Anthropic is really the default choice for any highly regulated industry.
Why is that?
Their entire founding principle is built around this idea of being useful, harmless, and honest. It's supported by an incorporated ethical constitution.
So that builds a lot of trust.
It makes them inherently highly trusted in areas like legal analysis, healthcare documentation, any compliance-heavy workflow where regulatory adherence is just paramount.
And they back that safety focus up with excellent long-form reasoning.
Yes, supported by a 200,000 token context window.
Now, that's not the 10 million of Llama.
No, but 200K is more than sufficient for processing entire contracts or vast regulatory documents or complete code bases in a single reliable request.
And the user experience seems to reflect that.
It does. Users often describe working with Claude as feeling like they are collaborating with a reflective senior analyst.
A reflective senior analyst. I like that.
It just demonstrates stability, it provides clear explanations by default, and it has a significantly lower propensity for hallucination compared to its immediate rivals. It's the definition of a stable, reliable partner for software engineering and legal work.
So if it offers this level of stability and trust, what's the barrier? Why isn't it the universal winner?
Two major weaknesses really stand out. First, the rate limits. Anthropic's infrastructure often imposes these really frustrating usage limits. They frequently interrupt iterative work. They break development sessions.
So for power users, that's a deal breaker.
So anyone needing continuous, high-frequency, complex workflows, this throttling is extremely frustrating, and it forces them to move tasks to other platforms.
And the second major weakness, data staleness.
So it's not connected to the live internet.
Correct. Claude lacks native, real-time internet access. This means that for any task that depends on current events, or fluctuating market data, or breaking news, Claude is at a major disadvantage.
So it's perfect for a fixed, historic document,
Like a contract signed last year, yes.
but useless for real-time market forecasting.
Or crisis response. Exactly.
Which brings us neatly to xAI's Grok 4. This model is engineered for the exact opposite, pure speed and up-to-the-minute awareness.
Grok has really created a new niche in the market. Its core strength is its truly unmatched real-time data access.
And that comes from its deep integration with Platform X. Deep and instantaneous. It allows it to process up-to-the-minute social discourse, trends, breaking news.
So for speed-sensitive applications,
It's critical. Think brand monitoring, crisis management, rapid sentiment analysis in financial markets. If you need to know what happened 60 seconds ago, Grok is the undisputed leader,
and its reasoning capabilities are actually surprisingly competitive.
especially in its think mode, yes.
What are the stats on that?
The think mode has put Grok right alongside the big proprietary titans. It achieved 93.3% accuracy in the AIM Math competition, the American Invitational Mathematics Examination.
So it has serious logical chops.
It does. And on top of that, it is blazing fast. Our latency tests clocked the average response at a mere 67 milliseconds. Speed really defines its utility.
But of course, there are significant trade-offs. Let's talk about its limitations and creativity.
The poor creative output is a serious limitation, yes. Grok scores pretty low, around a 6 out of 10 in creativity assessments.
So what happens when you ask it for something creative?
When you ask for nuanced writing or fictional ideas or complex marketing copy, it just tends to be very cautious, repetitive, and uninspired. It is not the tool for exploration.
And the cost to maintain that real-time connection must be enormous.
Staggering. Which leads to massive sustainability questions.
It operates on the Colossus supercomputer, right?
It does, which requires an estimated 200,000 H100 GPUs. That kind of massive computational backbone raises critical questions about energy consumption and the sheer environmental impact.
So organizations have to weigh that ethical cost against the benefit of speed.
They absolutely do.
Okay, we're going to transition now to the open source contenders. And this is where the strategic choice gets really complex.
It does, because you're getting near premium performance at dramatically lower operational costs.
But the technical requirement, the expertise you need to deploy it, is significantly higher.
This segment really represents the true democratization of AI. You get to buy the engine, but you are responsible for integrating the cooling system, the transmission, the whole dashboard.
And the biggest hurdle for organizations here is navigating what our team calls the benchmark trap.
The benchmark trap. It's this dangerous discrepancy between a model's high score on a leaderboard and its messy, unpredictable, real-world practical performance.
So let's start with Meta's Llama 4. It's the open source leader, and it's largely defined by its context supremacy.
Unrivaled at 10 million tokens. That context window alone just sets Llama 4 and its variants like Scout and Maverick apart from everyone else in the open source space.
So it's the perfect solution for massive data inputs.
Systematic literature reviews, processing huge proprietary code bases, crunching thousands of internal corporate documents. Yes.
And the benefits of open source are obvious. Complete customization, no vendor lock-in, budget-friendly.
Exactly. The flexibility is immense. However, we have to stress the benchmark versus reality trap, and it's particularly true for Llama 4.
It scores well on paper.
It achieves impressive benchmark scores. Maverick gets a 34.5 in coding, which suggests really strong competence. But real-world application paints a very different picture.
Our analysis featured a specific test where developers challenged Llama to build a pool game application. What was the outcome of that?
The outcome was very revealing. Llama produced the basic functionality, the bare bones of a game, but it completely lacked any sophisticated physics or realistic graphics integration or complex object interaction.
And how did that compare to a closed model in the same test?
A proprietary rival in the same test generated a complete polished interface with realistic interactions and physics, a playable game.
That's a huge gap.
It's a massive gap, and it highlights that while Llama is excellent at generating new standard code, developers report significant struggles when they try to use it for practical, iterative tasks.
Like debugging existing code.
Or modifying legacy systems. The benchmark doesn't measure the model's ability to handle the real messiness of production.
Now, DeepSeek is a fascinating one because it really challenges the idea that you need billions in capital to compete.
It does. It achieves elite reasoning power through sheer efficiency. DeepSeek R1 is a genuine reasoning powerhouse.
How does it do that?
It uses sophisticated reinforcement learning techniques to solve complex math, coding, and logic problems. Our tests show it consistently matching the performance of OpenAI's earlier proprietary O1 model.
So that's state-of-the-art capability without the massive investment.
Exactly. And this efficiency is driven entirely by their implementation of the MoE architecture.
Can you give us an example?
The V3 model's the perfect illustration. It has 671 billion parameters in total, but only 4.5 billion are actively engaged for any specific query.
That's an extreme level of efficiency.
It is. DeepSeek is the clear cost-benefit leader in this space. They are delivering near-premium performance at significantly reduced computational cost. They're redefining what's required to compete at the top.
So for an organization that wants that cost efficiency, what's the catch? What's the infrastructure requirement?
The catch is the upfront investment and the in-house expertise. While the operating cost is low, you need high upfront hardware requirements to get optimal performance.
So specialized computing resources.
Yes, often meaning premium prices on platforms like SiliconFlow. And furthermore, DeepSeek just lacks the polish and the turnkey integrations of its proprietary rivals.
So you need a dedicated technical team.
You need a dedicated in-house team to deploy it and maintain it effectively. It's high reward, but it's a high expertise entry point.
Let's talk about Mistral AI, a critical player, not just for performance, but because it's a strong European alternative.
And that's a huge deal for many companies. Mistral's core strength is its Mistral MoE architecture. It offers incredible cost efficiency, enabling high performance on very modest budgets.
And it's fast.
Described as incredibly fast. It's great for real-time, latency-sensitive applications like interactive chatbots, and crucially for European organizations, it provides a strong data sovereignty option.
So it's an ideal choice for GDPR compliance.
And for avoiding U.S. vendor lock-in risk, yes.
But similar to DeepSeek, I assume the expertise hurdle is pretty substantial.
It is. Mistral is not designed for non-developers. It requires a steep learning curve. Your organization has to employ specialized engineering expertise for deployment, for maintenance, for building all the necessary integrations.
And the ecosystem is smaller.
It is. There are limited third-party tools compared to the giants, which just means you're building more of it from scratch.
And our last open source contender is Alibaba's Qwen 3. They're making noise primarily through their sheer speed of development.
Their pace is just relentless.
Mm-hmm.
Alibaba launched 228 model variants in 2025 alone. That kind of rapid iteration forces the slower U.S. labs to respond.
And they're innovating on the architecture itself.
They pioneered what they call a hybrid attention architecture. It allows for training that is 10 times faster and cheaper than previous models, making these rapid updates commercially viable.
And they have strong multimodal capabilities as well.
Yes, especially with the Qwen 2.5 VL model. It excels at visual linguistic tasks, like analyzing a complex diagram and then generating the corresponding code.
But like Llama, it struggles with existing code.
Exactly. It suffers from that same inconsistency. It performs well when generating new code from scratch, but it shows a distinct weakness when you ask it to debug or refactor or alter existing code.
So it's difficult to use for long-term code maintenance.
Very difficult. And if synthetic media generation is your goal, it's not the best choice.
The visual generation lacks realism.
Significantly. Images and videos generated by Qwen tend to look very generic, very artificial. It fails to match the quality of the specialized visual tools that are available. It's functional, but it's not aesthetically sophisticated.
Okay, let's move to two specific tools that aren't foundational models, but are more like specialized ecosystems. And they solve some high-value problems, or in one case, create some new ones.
A fair assessment.
Let's start with Perplexity AI's Sonar. It's a dominant force in research.
Perplexity AI absolutely dominates the niche of research, journalism, and knowledge management.
And its key strength is the citation.
It's the seamless integration of real-time search and citation. It doesn't just generate text. It provides answers with verifiable links to the sources it indexed.
Which sharply distinguishes it from a traditional chatbot that might just hallucinate a source.
Or rely on outdated training data. For any professional who needs quick, verifiable information, that citation capability is transformative. It fundamentally changes the trust equation.
It's an indispensable tool for fact-checking.
It is. And the Sonar interface is very clever. It's a hub that unifies access to multiple LLMs, GPT-4, Claude, their own model, all in one research-focused interface.
So you get the best reasoning from various providers, all tied to verifiable data.
Exactly.
But what are the limits of its exploratory reasoning?
Because Perplexity is fundamentally a search system at its core, it struggles with that. If you present it with a complex scientific problem that hasn't been directly addressed in its indexed search results.
Or a purely theoretical question?
A theoretical multi-step question, yes. It just can't use the deep generative rigor of an O3 Pro model. Its output quality is strictly limited by the index sources it can find. So it's excellent for synthesis, but poor for true intellectual exploration.
And finally, we arrive at Microsoft Copilot. For millions of people, this is their first exposure to generative AI in their workflow.
And that's thanks to its deep integration into the 365 ecosystem.
But our research identified this as a massive critical warning. We've dubbed it the integration trap.
This is perhaps the most crucial alert for large organizations in our entire analysis. It really demands attention.
So Copilot's core strength is its convenience.
Yes. Deep integration into Word, Excel, Teams, Outlook, backed by Microsoft's robust corporate security. That convenience is a very powerful lure for the existing M365 user base.
But our findings show that convenience has come at the cost of quality, and it's leading to demonstrable negative productivity.
It is.
Can you walk us through why that quality gap is so real compared to its competitors?
The quality gap is systemic. Copilot consistently underperforms compared to dedicated reasoning models like Claude or GPT in detailed reasoning and instruction following.
What's the root cause?
It's twofold. First, it often relies on simplified, faster model variants that just lack the complexity and fine-tuning of its competitors. Second, and this is critical, it struggles with state management.
Meaning it can't track complex instructions.
Not across multiple steps or applications. It functions like a single-turn chatbot pretending to be a multi-step agent.
And the productivity data is it's
Wow.
staggering. Our research review showed quantifiable evidence that users experience 23% less efficiency when using Copilot.
It's devastating for actual workflow.
Yeah.
Users are spending more time correcting the flawed outputs.
Like an inaccurate Excel formula or a poorly drafted memo.
Or a nonsensical email summary.
Yeah.
They spend more time fixing it than the time they saved using the automation in the first place. That is the integration trap.
So organizations adopt it for the convenience, but the poor quality forces users into this corrective labor, creating a net negative productivity impact.
Exactly. It lacks any real autonomy. It just can't handle complex, chained, multi-step, agentic workflows that require sophisticated planning.
So not only is Copilot slowing teams down, but there's this serious collateral damage issue. It's actually hurting wider AI adoption.
Yes, the knock-on effect is profound. Our research shows that a significant 67% of users who have a frustrating initial experience with Copilot.
They just reject other AI tools later on.
They do. This initial bad taste acts as a barrier to wider, more beneficial AI adoption across the enterprise.
So what's the takeaway?
For any mission-critical task, or any workflow requiring complex reasoning, enterprise clients have to look for stable, quality alternatives.
Like Claude Sonnet.
Claude 3.5 Sonnet is a great example. You have to avoid relying solely on Copilot until Microsoft significantly addresses that underlying model quality.
Okay, this has been an exhaustive deep dive into these 10 major players. We've exposed the capabilities and the critical weaknesses. Now, let's synthesize all of this into clear, actionable recommendations for you, the listener.
Because there is no single winner.
No, but there is a definitive best choice for every specific use case.
Let's break down the optimal choices. So, for reasoning pure complex logic, high-stakes analysis, advanced math OpenAI's O3 Pro and Google's Gemini 2.5 Pro in deep think mode still set the standard. They command the frontier of analytical depth.
And if your team is focused on codification reliability and practical development, where you need stable, maintainable code,
We strongly recommend bypassing the instability of the GPT-5 rollout. Go with the proven workhorses. The stable GPT 4.1 and Anthropic's dependable Claude 3.5 Sonnet.
multimodality is still dominated by Google Gemini 2.5.
It is, given its true native processing across all media. However, Alibaba's Qwen 2.5 EL offers a strong, rapidly iterated open-source alternative if you're focused specifically on visual analysis.
For the cost-benefit and open-source category, the choice really depends on your data size.
Right. DeepSeek R1 is the winner if you need premium reasoning for a fraction of the cost, thanks to that MOE efficiency. But Llama 4 Maverick is the leader if you need to process massive amounts of data thanks to its unrivaled 10 million token context window.
And finally, for enterprise stability and safety, especially as a high-quality alternative to the problematic Microsoft Copilot.
Claude 3.5 Sonnet provides the best balance: stable performance, robust safety, and reliability for highly regulated workflows. It's the safe choice.
Before we move on to strategy, let's quickly recap the 3 critical alerts that every organization must be monitoring as they deploy their 2025 AI strategy.
First, the GPT-5 rollout regression. The abrupt feature changes, the quality degradation, the stability issues. It all means you have to exercise caution.
Wait for stabilization.
Wait for it to stabilize before you migrate any critical production workloads. For now, stability clearly trumps novelty at OpenAI.
Second, the Gemini behavioral instability.
The emotional collapses and memory leaks are not simple bugs. They are deep, workflow-breaking instabilities in the model's architecture.
So you need to implement stringent validation checks.
On any mission-critical Gemini output, absolutely. You cannot deploy it blindly in a customer-facing role yet.
Third, and this is maybe the most urgent for our enterprise listeners.
The measured negative productivity of Microsoft Copilot. If your teams are using it for anything beyond simple email drafting, you risk slowing them down. Measure its real-world impact rigorously before you commit to a wide-scale deployment.
And finally, a general warning. Always be wary of the benchmark trap.
Never forget the gap between high leaderboard scores and the practical reality of execution, particularly with models like Llama 4 and Qwen. Test them with your actual specific use cases before you commit any resources.
So what is the overarching strategic path forward?
The path is definitive. You must embrace the no single model strategy. Organizations have to plan for model diversity, for stacking multiple models that are optimized for different tasks.
This diversity isn't just a preference, it's really an insurance policy.
It is. It guarantees resilience against vendor lock-in, it shields you from catastrophic service outages, and it guards against that sudden disappointing quality degradation we saw with the GPT-5 transition.
So our team has synthesized 3 core adoption recommendations for you.
First, determine the end goal first. Are you automating complex legal paperwork? Building next-gen code? The goal has to rigorously define the tool you select.
Second, prioritize based on context window or multimodality.
If you deal with vast data sets or code bases, context is paramount. Think Llama or GPT-4 Mini. If you analyze media and video, multimodality is your primary requirement. Think Gemini or Qwen.
And third, and we really can't stress this enough,
Avoid chasing benchmarks alone. Test your chosen models with your actual specific messy use cases. Lab scores only measure theoretical capability. They do not capture the real-world chaos of a production environment.
looking ahead to future-proof that strategy, what trends should organizations be monitoring into 2026?
The trend line is pointing overwhelmingly toward MOE architectures. The approach from Mistral and DeepSeek is going to displace the old monolithic models.
They're just too efficient.
They're too efficient and cost-effective to justify the premium overhead of the old way.
We should also expect cost commoditization to accelerate.
Dramatically. As competition intensifies, we expect costs to drop from dollars per million tokens to pennies next year. And that enables massive, entirely new applications that were previously too expensive to run.
And finally,
Watch the blurring line between AI assistant and AI agent. The ability for a model to invoke complex tools and execute multi-step workflows without constant supervision is becoming table stakes. The future AI won't just answer your query, it will take independent actions to fulfill your high-level tasks.
so to wrap up this definitive guide from the Urban Herald team, just remember this. In the chaotic, high-stakes AI landscape of 2025, there is no universal winner.
No.
Success is wholly defined by the smartest balancing act you can strike between capacity, cost, and your specific nuanced use case.
We really encourage you to use this rigorous breakdown to match the tool to the task. Deploy the specialized reasoning models for logic. Use the generative models for creative exploration, and always prioritize stability over novelty when it comes to critical production workflows.
And that leads us to the provocative thought we want to leave you with. Based on the startling efficiency we've seen from open source challengers like DeepSeek and Llama,
If the future really does involve these highly efficient open source models matching proprietary performance for just a fraction of the cost, does the necessity of paying that massive premium for closed source models truly still exist in the long term, even for stability?
It's a question that challenges the entire business model of the proprietary giants.
And you need to be considering that long-term cost equation now before your entire infrastructure gets locked in.
Thank you for joining the Urban Herald team for this deep dive into the 2025 AI landscape. We'll keep tracking the benchmarks and the instability so you don't have to. We'll see you next time.